Hey everybody, we're continuing talking about proving these identities. And we're not going to introduce any more identities. We're still going to use these basic ones to prove a few more examples. The more examples you see, and especially the more examples you do and even struggle with, the better you're going to become. So we start off with the Pythagorean identity. Cosine squared plus sine squared equals 1. And it's two consequences. If you divide by cosine squared, if you divide by sine squared, you get these two different versions. But it's really, these three are really the same thing. And then these six we've known since the beginning. Tangent is sine over cosine, cosecant is just 1 divided by sine, etc. A very popular strategy is to convert everything to sine and cosine, which is what we did here. We convert it to sine and cosine, and then we notice that I've got two things that need to become one thing. So that motivated me to get a common denominator and then add the two fractions. Now I've got one thing. So now what? Well, then I recognize that sine squared plus cosine squared is this identity, and that just equals 1. So I replace that with 1, and now what? Well, I know I want a secant and a cosecant, and I go back to this. I know that secant is 1 over cosine. Cosecant is 1 over sine, and that's what I've got. I've got 1 over cosine. I've got 1 over sine. I can split them up into two fractions that are now being multiplied to each other. And then I can switch these two around because multiplication is commutative. Here, this one was pretty easy. You switch everything to cosine and sine. The cosines cancel out. I'm showing that work. I'm not just slashing, I'm showing. And then distribute the sine, and the final expression kind of falls in your lap. Here, we didn't convert to sine and cosine. We saw that we had a 1 minus tan squared, and we knew that if we expanded this out, I would get tan squared, which makes me think of this. And when I do expand it out, I've got a 1 and a plus tangent squared, and 1 plus tangent squared equals secant squared. So I rearranged my terms. I replaced 1 with tangent squared with secant squared, and voila, I get the same thing. We're going to do this problem again, and we're going to repeat these proofs, but in a different way, because there's more than one way to do it. So how else could I prove that the left side equals the right side here? Let's switch to purple. And we're gonna start on the right side. You can start on the left side or the right side, it does not matter. And on the right side, as long as you just don't cross that equal sign, okay? I see a secant squared, which makes me think of that. So right off the bat, I can replace secant squared with 1 plus tangent squared theta minus 2 tan theta. And then now what? This might be challenging to see. I can rearrange these terms, and I can factor. I can factor this trinomial. This was part of your homework from Monday, or I don't know what day, a couple of days ago. Can I factor this? Let me give you the polynomial version. 1 minus 2x plus x squared. Can you factor that? Two numbers that multiply to 1, well, that's 1 and 1. There's no debate there. Two numbers that multiply to x squared, I could have plus x and plus x, or I could have minus x and minus x. They both multiply to plus x squared, and it turns out this is the correct factorization because that gives me my middle term of negative 2x. So same logic here. This is going to be 1 minus tangent of theta times 1 minus tangent of theta. And those two binomials are the same, so I can write that as 1 minus tangent of theta squared. And looky there, it's exactly what I needed. This one, how are we going to do this one? Well, I see that secant squared again, so let's use it. I know that 1 plus tangent squared theta equals secant squared. And this is secant squared minus 1. Well, good news. I've got a 1 in there. So I can, and now I know this equality is for sure true. We proved that. So here I can cross the equal sign, no problem. I can subtract 1 on both sides, and I get secant squared theta minus 1 equals tangent squared. So I'm going to replace this with tangent squared. I don't know if that's a good idea or not, but we'll see. All right, now what? I want to get this. Well, now let's convert to sine and cosine. I know tangent squared is sine over cosine, so it must be sine squared over cosine squared equals, I'm sorry, over sine theta. And then now I've got a fraction divided by sine. So I've got sine squared theta over cosine squared theta. You see all the work I'm showing. Times, I switch from division to times. I multiply by the reciprocal. And what happens here? Let me start using some arrows. Well, the sine squared on the left, one of those signs cancels out with the sine on the bottom. So I just have sine of theta divided by cosine squared of theta. And now, okay, so now I'm getting a little bit happier because it looks closer to that. At least I've got a sine in the numerator, but I've got a cosine squared in the denominator where I really want a 1 minus sine squared in the denominator. What am I to do? Well, remember, cosine squared plus sine squared equals 1. If you subtract both sides by sine squared, you get cosine squared equals 1 minus sine squared. And I hope you see that you are right on top of it. You can replace cosine squared with 1 minus sine squared because they are the same. And that's the proof. It's done. So what did I do here? The first thing I did was used a Pythagorean identity. The fact that secant squared equaled 1 plus tangent squared, or I'm sorry, the fact that tangent squared equaled secant squared minus 1. So I replaced secant squared minus 1 with tangent squared. And then what did I do? Recognize that tangent is sine over cosine. So tangent squared must be sine squared over cosine squared. From here, I've got my pre-algebra skills. I've got a fraction divided by something. So if I want to divide something with fractions, I switch to multiplication and I switch the divisor to its reciprocal. And then again, pre-algebra, two of these signs cancel out, and I'm left with sine over cosine squared. Now what? Cosine squared, you have to be sensitive to cosine squared plus sine squared equals 1. So I can solve for cosine squared. Cosine squared equals 1 minus sine squared, which means I can replace cosine squared with 1 minus sine squared, and I did it. So I used the Pythagorean identity twice, in two different ways, but twice. Last one, and here we are in for a new strategy. It's called the conjugate. Proving something by the conjugate. All right. So let's start again with this is the last one. So hold on, hang on there. All right, if I subtract cosine squared on both sides, please recognize that what you got there is a difference of squares. And difference of squares are always factorable. That would factor into 1 minus cosine times 1 plus cosine. And now I want you to see that these two things, these two binomials are conjugates of one another. So if you multiply two conjugates, you're going to get a difference of squares, is what I'm trying to say. So that is the strategy I'm going to use here. How would you ever know or think to do that? First of all, practice. But second of all, you're going to learn that that's kind of a clue. You got 1 plus cosine. You see how it's 1/2 of the difference of squares factorization? That's your clue. So let's try to see into the future. What I'm going to do is I'm going to take that first fraction, sine g over 1 plus cosine g, and I'm going to multiply it by the only thing I can multiply, 1, but I'm going to multiply by its conjugate. So just think, what's the consequence of that? When I take 1 minus cosine times 1 plus cosine, it's basically this. That will equal sine squared. So that I'm going to change that denominator into sine squared. And that's going to cancel out with this sign. And I think some nice things are going to happen. So let's see where it takes me. Let me clean it up a little bit. First of all, I want to be, remember, I'm the lawyer. You're a lawyer. We have to be clear because we don't want the reader to be thinking, what happened to this fraction? What happened? So you have to write it, continue writing it. In the numerator, I've got 1 minus cosine g times the sine of g over 1 minus cosine squared of g. Now 1 minus cosine squared of g, I just tried to describe before, is the same thing as sine squared of g. Two of those sines cancel out, so I'm left with 1 minus cosine of g over sine of g plus 1 plus cosine of g over sine of g. Okay, now let me pause here because I'm done with that first that first execution. The point of this problem was, you see a 1 plus cosine. So this isn't always going to work, but there are lots of ways to prove these things. But 1 plus cosine, you need to recognize that that is 1/2 of the conjugate pair that would give you 1 minus cosine squared, which is the same thing as sine squared. And so that means that you could express that as sine squared, which will cancel out with a sine. So anyway, I multiply by 1 minus cosine over 1 minus cosine, and then simplify, simplify, and simplify. So now I need to think, what can I do now? Well, I'm kind of stoked because I see two fractions that have the same denominator. So let's just add them up. I mean, that's got to be right. Let's see. So the denominator would be sine of g. I've got 1 plus 1, so that's 2. Negative cosine g plus cosine g. Aren't those opposites? Doesn't that just add up to 0? And now I hope you can see how close we are to being done. 2 over sine of g is the same thing as 2 times 1 over sine of g, which is the same thing as 2 times the cosecant of g. So that is proof. So please, please, please practice. Even if you feel like you're not getting them, just the basic fact of you practicing them, it will help.